Okay, so in this video over here, we'll be talking about how to find the derivative of functions when they're in the form of x to the power of n. So when it's in this form, it's actually quite convenient to differentiate, and you want to actually put it into this index form to differentiate many expressions which you probably wouldn't be able to differentiate without converting it back into index form. Now, the trick here is that we want to leave this a coefficient right in front. So you notice over here that if the original function has a in front, some sort of constant, then I'm just going to leave it in front as well. We'll just multiply it at the end. What's happening here though is what I want to do is I'm going to chuck this n to the front. So this n over here goes to the front, so you can see that it's now beside the a as another coefficient. It's just that you're going to multiply both these now, and this n over here is going to be subtracted by 1 so that it turns into this n minus 1. And so those are the three main steps. You want to leave the a alone, chuck the n to the front along with the a, and you want to subtract the n by 1. So there's that. And suppose that you're not just finding the derivative of one term. It's quite simple to actually find the derivative of multiple terms, because if you have a function h and you have h as a function of, well, multiple different functions separated by a plus or minus, so this plus over here can really be plus or minus, then what you're actually doing is you're actually finding the derivative of each function individually, and you're just transferring them over, and they're still separated by the same plus or minus as before. So we'll give these a shot in this first example, just to demonstrate how we can use both these rules to help us differentiate. Now, over here we got some sort of cubic. So first of all, we're not trying to find an alternative expression, so we can't just say this is equal to. We're going to say that this new function, this gradient function f dash, is equal to x cubed over here. So notice here there's nothing in front, so your a value here is really 1. And what you want to do is you want to grab this 3, chuck it to the front, so you have 3 x, and this 3 over here is 3 minus 1, 2. So in case that's not clear, it's actually just 3 minus 1. Minus 3. So you can treat your a value here as negative 3, if you will. Okay. And seems like it has an index of 2, so I'm going to multiply by 2 in front. Still have an x, and remember the top now becomes 2 minus 1. So you have index of 1 now, or just x. And next up we have minus 5x. Now this x over here, you can treat this as x to the power of 1. So what you really have is minus 5 times 1. And this x over here, if you have 1 minus 1, of course you have 0. X to the power of 0 is really just equal to 1. So I'm just going to leave this as negative 5. And this 2 over here, this one over here will become 0 for f of x. Okay. And if we just clean up the algebra here a little bit, we're going to get 3x squared minus 6x minus 5 as our derivative function. Okay, so it's quite straightforward when everything's already in index form. So let's go down and have a look at something where we have to do a little bit of work to actually get our final function. Okay, so over here, as I said before, we need to convert everything to index form before we can actually find our derivative function easily. So this one over here needs a bit of manipulation. So I'm going to start with manipulating f, not f dash. So x to the power 4 stays the same. Plus, now 1 on x is the same as x to the power -1. So if you treat this as a small, well, an index of 1 at the bottom, remember that if you have a positive index at the bottom, this can actually go to the top as a negative index. Minus 2. Now root x over here, we know the square root is x to the power half. And plus 3. Of course, we know that the constant turns into 0, so we're just leaving it as that. So now we have f dash. So bring the 4 to the front. X 4 minus 3, sorry, 4 minus 1 is 3. Plus, now coefficient of 1 here. But the trick here is that this -1 must go to the front. And the index now is -1 minus 1. That's -2, but we'll worry about that later. Minus 2. Now we bring the half to the front. Keep the x. We have half minus 1 at the top. Okay, just keep these indices in brackets. You never have too many brackets. They're really just tools there just to help you make sure that you're not going astray and ruining your order of operations. I mean, it's up to you if you want to keep the brackets there, but I personally like to put them there. Okay, so 4x cubed stays the same. -1 over here, turn to negative, minus x to the power -2. Minus, now this 2 and half here can cancel each other out to get -1. X power -half. Okay, just squeeze down more pleasant form. So going back to positive indices, we're going to have 1 on x squared, and this -half here is going to be 1 on root x. Okay. Moving on to the next example here. Let's make a margin over here. Alright, so for this one over here, now everything is in index form, but we actually haven't dealt with anything that requires a vincule. We're not doing any fractions here. And if you recall the rule from above, so I'll just quickly scroll back up, that both, well, not both these rules, this rule over here only allows plus and minus. So this means that when you have a fraction, we can't use multiplication or division. So what do we do when we have a fraction? Because we know the fraction over here really means division, right? So in this case over here, you need to find another way to simplify this before you actually proceed. So what you want to be doing is, of course, we're going to be manipulating f of x. And we're going to be dividing each term in the numerator by 3x. Because remember that you can actually separate your numerator like so. If you do this, you're going to end up with 2/3 x plus 5 on 3 squared. This makes for a relatively simple derivative to find. So 2/3 over here just becomes, well, 2/3 x becomes 2/3. It's 5/3 over here. Now, if you want to just be safe over here, bring the 2 down so that you get 2 in front, and you get 1 as your new index, since you need to subtract this 2 by 1. So you get 2/3 plus 10 on 3x. Okay, don't know what happened here with my copy and paste, but it's bad. Okay, so this one over here. Not particularly tricky, especially with this one down here. We know that this is simply a negative index, so we can just say that f of x is really just 2x to the power of negative 2. Now, this one over here, well, we know square root means that we're going to be, what are we doing? We're going to be taking to the power of half, right? So this means that we want to square root x cubed. That's what it's trying to say here. So we're going to have x cubed, and we're going to be square rooting this, or taking this to the power of half. But what do we know when, or what do we know we can do when you have an index inside the bracket and an index outside the bracket? What you can do is you can multiply. Now, if you multiply the indices, you can expand those brackets. It's just like distributing your term on the outside whenever you want to expand your brackets. So what we're going to do here is we're just going to replicate this 2x to the power of negative 2. This 5 over here is going to be x to the power of 3 times half. So we have 3 on 2. Okay, so since everything is in index form, we can find out what f dash of x is. So we're going to keep the 2 on the outside, bring this negative 2 over here to the front. X and negative 2 over here is going to be subtracted by 1. So we know that's negative 3. 5 stays on the front. 3 on 2 goes to the front without subtracting. X 3 on 2 minus 1. Okay. Over here, 2 times negative 2 is 4. X to the power of negative 3. 5 times 3 on 2 gives us, wait, no, bad math, sorry, 15 on 2. And we have x to the power of half when you have 3 on 2 minus 1. Now, if I just scroll down here just to clean this up, of course that should be an accepted form, but since I don't like dealing with negative indices, it's really up to you. You can leave it in that form. But I prefer to say that our gradient function over here is negative 4 on x cubed plus 15 on 2 root x, if you're not a fan of fractional indices.